What I'd like to share with you now is a completely different approach, which actually would be complementary to any of those because it works in a very different way, but it overcomes treatment resistance in solid tumours. And we are just embarking on our clinical trials for that. So we just completed our first close on our Series A, which is a 10 million first close. And we are moving into clinic to have first patient dosed for the end of next year. What we have is the world's first neutrophil-based cell therapy, and it works on the innate immune system, the myeloid side, in order to essentially recruit the rest of the immune system into tumours. So LIfT was originally set up because after being in the industry for 15 years, I sadly lost my mother to pancreatic cancer. But really, I lost her to tumour escape or drug resistance, as we often recognise it as. And this is because obviously targeted therapies are fixed and tumours adapt. So to date, the industry has been very much focused on cytotoxic persistence for a specific antigen on tumours. And what we're moving things over to is stimulating a lasting immune response in a non-antigen specific manner to prevent tumour escape. And this is how we believe we can solve treatment resistance overall. So at the moment, we're awash in oncology with new on-trend targeted therapies, but they all fall foul of the same problem. So ADCs, bispecifics, multispecifics, they're all in the end going for a target. And we all know that the real problem in cancer isn't the actual target that they're going for. It's the tumour antigen escape variant or the antigen loss that goes on to seed metastases. And those metastases are what kills 90% of cancer patients. So the elephant in the room is if actually 90% of patients who die from cancer are doing so not because of the target, why are we all going for the target? And these metastases are very heterogeneous, and they become they are what becomes drug resistant and kills the patient. And how are they formed? Well, there's a very nice paper published in Cell on the left-hand side here, and this elucidates how T cells essentially are unable to capture these antigen loss variants. And the immune system has been set up in such a way that it is your innate immune system that is meant to go and kill those variants and bring them to the attention of the rest of your immune system. Now, the problem comes when your own innate immune system, which is dominated by neutrophils that make up the majority of white blood cells in you and your tumour, become corrupted and are not working properly. And when this happens, they no longer kill these antigen escape variants. So what this paper very nicely showed is where they used a murine model, they were able to demonstrate that when neutrophils were used that didn't exhibit this quality, essentially there was tumour escape and the mice would all die. When the neutrophils did exhibit this healthy quality, then those mice would all live. So it was a very black and white difference. And just to go to show this isn't just a mouse model thing, on the right-hand side is a paper that came out the same month. And this was showing that tumour control comes again from having the right type of neutrophils. So this was a retrospective study on 78 patients who had non-small cell lung cancer. And what they found here was that where you have pro-tumour neutrophils that have been produced from the bone marrow in a corrupted state, and hence this person's cancer is getting worse, when you just have bystander cells on the other side, as in nothing actually fighting the tumour from the neutrophil side, those patients do not have IO control. The immunotherapies don't work. However, when you have neutrophils that are anti-tumour and are actually able to work with the lymphoid system, so you have the myeloid system working with the lymphoid system, you get an upward spiral and you get what I call an immune cascade that attacks the tumour with the myeloid cells releasing IL-12, other things like OX40, 4-1BB ligands as well, making contact to stimulate them. And the lymphocytes have interferon gamma. And the ability to be stimulated by interferon gamma is one of the key facets of an anti-tumour neutrophil. So what's going on here? Well, on the left-hand side, we have a healthy responder. And in this system, the bone marrow produces healthy anti-tumour neutrophils. These create our immunosurveillance cells that will have threat recognition. They create an inflammatory cascade. They infiltrate and recruit other immune cells. And essentially, they destroy those cancer cells along with the T cells, and they prevent tumour escape. This then leads to a homeostatic mechanism working where the signals back to the bone marrow from positive cytokines are released more of these neutrophils. And that's what happens in us. When this goes wrong, and instead you get a corrupted bone marrow, akin to leukemia, it comes back to the bone marrow and how white cells are produced. The bone marrow produces these corrupted pro-tumour neutrophils that are only partly formed. They actually help the tumour grow. They don't recognise escape variants, and they help angiogenesis of the tumour. So your best friend becomes your worst enemy. And in this situation, the tumour then actually starts sending negative cytokine signals back to the bone marrow to produce more of the wrong kind of neutrophils, and it's a downward spiral. And this is an immunotherapy non-responder. And this is so predictable that this paper that was published in the Journal of Translational Medicine on patients, it took 100 non-small cell lung cancer patients. And on the left, you can see that by far the most prolific white blood cell in the body were the neutrophils in green there. And they were able to mathematically predict how long somebody would survive just by putting in what proportion of anti versus pro-tumour neutrophils they had to accurately give the month on which the patient would die. And sadly, it worked. And so it just tells you how powerful the type of neutrophil you have is. So what we're doing at LIfT is we're intervening by using our HSC or iPSC derived cell therapy that's allogeneic, and we give these super powerful anti-tumour neutrophils. We call them Immunomodulatory Alpha Neutrophils. And this provides a reset, and it challenges the existing pro-tumour neutrophils and instead creates this immunosurveillance, this inflammatory cascade, and starts creating a tumour microenvironment that actually instead overpowers the incumbent neutrophils, the TANs, and is able to then send the right cytokine signals back to the bone marrow to produce more of the right kind of neutrophils, and you get a reset. And these are the immunotherapy responders. And that's how our therapy works. And we can repeat dose as necessary. So just to demonstrate how this works, so we can infiltrate and enable access to the tumours in a way that hasn't been seen with T cells and NK cells. And on the right here, what you can see is a diagram that shows the improvement in tumour killing and infiltration. We also are able to increase the performance of the T cells, and in particular, you can see the difference with PD-1s when you have the right neutrophils and wrong neutrophils in tumour size. And lastly, in metastasis formation, you can see it prevents the formation of these metastases. So what we're doing now is we are looking to raise a further 15 million in Q1. And we already have 2 funds lined up for this, so half of that is already accounted for. And we're looking for 2 other funds to join the round. And this will enable us to go through not only our clinical trial that we're currently doing, but also it enables our iPSC platform and the engineering we're doing for a 2nd generation therapy. And we have pharma partners as well joining us for that. So if there are people who are interested in finding out more, please come and have a chat with me. And here's my email and phone number. Thank you very much.